There are many concepts spanning mathematics and computer science required to understand modern-day encryption. But rather than diving straight into bit flipping and modular arithmetic, let us ease in with one of the oldest and most well-known ciphers, the Caesar cipher. Let us start with a little history. The Caesar cipher is named after Julius Caesar, who famously used it to protect sensitive military messages during his campaigns. However, Caesar was almost certainly not the inventor. Shift ciphers predate him, but his documented use brought them into the historical record. What makes his cipher notable is that it is widely considered the first systematic application of mathematics to the problem of concealing a message. Its simplicity made it practical to use by hand, but as we will see, that same simplicity also makes it trivial to break. So what exactly is a shift cipher? In a shift cipher, each letter in the message is replaced by the letter a fixed number of positions ahead in the alphabet. That fixed number is the key, an integer from 0 to 25. The sender uses the key to encrypt, and the receiver uses the same key to reverse the shift and recover the original message. For example, with a key of 3, A becomes D, B becomes E, and Z wraps all the way around to C. We can use the Caesar cipher on the standard 26-letter Latin alphabet from A to Z. Beneath this alphabet we can place a second row, the cipher alphabet. When the key is 0, both rows are identical. Watch what happens as the key increases. The cipher row slides forward, each letter shifting ahead by the key amount. And back to 0, the rows align again. With a key of 3, the plain alphabet is on top and the cipher alphabet has slid 3 places forward. A is above D, B is above E. To encrypt any letter, read the one directly below it. If we change the key to 8, H is now sitting directly above P. Decryption is just the reverse. Find the letter in the cipher row and read the plain letter directly above it. P is below H, so P decrypts back to H. Let us take the word hello and write every letter as a capital letter. We just do this to keep things consistent. With key 8, the cipher row has shifted 8 positions forward. Find any letter in the plaintext row, and the cipher letter directly below it is the encrypted version. H is above P, so H becomes P. E is above M, so E becomes M. L is above T. The second L encrypts the same, so we get another T. And O is above W. Reading across the cipher row, hello becomes PMTTW. Let us decrypt. We take PMTTW, look each letter up in the cipher row, and read the plain letter directly above it. P is below H, so P decrypts to H. M is below E, so M decrypts to E. T is below L. As before, T decrypts the same, so we get L. And W is below O. PMTTW decrypts back to HELLO. Same table, same key, just read in the opposite direction. And that is the Caesar cipher, an ancient and simple example of symmetric encryption.